Hello everyone, welcome back to my channel. Today let's go over a Leetcode hard question that I just solved on my own. So really happy about this, and just goes to show you that I'm having like a rock star week on these pair problems, because as soon as I started solving the what is it called? There was like a medium question. I forgot the name of it. It was like um it was basically like nums of I plus nums of j plus I minus J or something. I think it was like best sightseeing pair. That's what it was. Okay. And then I just started solving similar questions and they all started clicking. So again, I'm really happy that I was able to solve this one on my own. So let me show you how I did it. And basically the intuition is pretty similar, right? You have this inequality and you want to find the number of pairs to the right, as we've discussed, that satisfy this difference. So basically nums of I minus nums of j is less than or equal to this minus this plus difference. So the easiest way to do this obviously is just n squared. So let's just try to go, and this is what I used to do. So for j in range I plus 1, length of nums 1. So just basically copy the equation. So diff is an integer and we want to return an integer. So let's declare that. So if nums of, just copy this, minus nums of 1 of j is less than or equal to nums of 2 of I minus nums of 2 of j plus difference, then that's a new pair. And then at the end, we can just return the answer. So this works, but obviously it's going to be too slow because this extra loop is n squared, n times n. So let's let this time out. And let me show you the solution that I came up with on my own. So basically, if you make some observations here, this, let's forget about the diff first. Let's see what we can do with this equation. So if we copy this here, forget about this. This minus this is less than or equal to this minus this. So basically, let's substitute some numbers. 5 minus 3 is less than or equal to 4 minus 2. That's true. Why is it true? Because 5 minus 4 is equal to 1. And 3 minus 2 is equal to 1. 1 is less than or equal to 1. So that's true, right? So as long as this is true, then we can just go ahead and say it's true, because we want to compare the difference at the same index and say, hey, is anything to the right, are any pairs to the right of the same index meeting this inequality? If they are, then it's true. So basically, we want to look for nums of 1 of I minus nums 1 of j. And this difference, we'll need to add difference to it. And then when we go through, again, because this left side doesn't have difference, so everything to the right plus difference. So, and then we have to add it. So basically, we're just going to make the right side nums of 2 of I minus nums 2 of I plus difference. And then we're saying, hey, is the inequality less than or equal to, if the current pair minus this is less than or equal to this minus this plus difference, then we can go ahead and say, hey, the differences cancel out on the left side, so that's a new pair. So once you know that, it's actually pretty easy, because you just, let's go through nums of 1. So the whole idea is to turn this from n squared into n. So let's call this d. And we want to append what now? Well, everything, this minus this plus difference, right? Because nums of 2 of I minus nums 2 of j plus difference is what we need. So it's going to be nums 2 of I minus nums 2 of j plus difference. And now if we go over nums 1 again, let's print n, and then let's print d of I plus 1 to the n, and that will, okay, nums 2 of I minus nums 2 of j plus difference. Nums 2 of I, we're looking at the same index on the right side. And okay, so so instead of n, again, we're looking at the differences. So the current difference is just going to be nums 1 of I minus nums2 of I, right? The difference here compared to the difference here plus this. So we're just rearranging the equation. And then let's print cur diff. So we just have to ask, okay, how many elements on the right side are less than or equal to this one? So now you have 2 less than or equal to, or so it's going to be 1 here because 0 is less than or equal to 1. 1 is less than or equal to 1, so the answer is 3. Here it's going to be 0. There's nothing on the right side. Here it's going to be 5 plus 4 plus, let's see here. So the current difference and, oh, sorry. That's what it's supposed to be because you always have to do I, J, I, J. So there has to be 2 I's and 2 J's on both sides. So we're just pre-computing this plus the difference for this side because this has an I and a J, not an I and an I. So now you can see that that lines up pretty well. And then now we just have to count for A and D, I plus 1 to the end. If current difference is less than or equal to, so we have this inequality, A, then answer plus equal to 1, and then we just return answer at the end. So as you can see, that works, except this is still too slow, but this is just demonstrating what we want to look for. So instead of doing this, why don't we go ahead and do a binary search? So the binary search condition is this has to be sorted, right? So let's go ahead and create a sorted list of D. And then what do we discard? Well, we discard this plus the difference because that was the current one. We want everything to the right. So sl.discard cur diff. And now let's print SL. We just want this and this to line up. The only difference being this is sorted. Cool. So it doesn't look right. Oh, plus diff because this is not having the diff. We want to do that to get rid of this side. Okay, so now this is the same thing, Okay. Cool. So how do we find how many elements in here are bigger than or equal to this? Well, we just do a bisect left. So BL equals bisect left inside of SL, current diff. And if we print BL, you can see that we get index 0 because that's all fine. Index 0 to the end is fine. Index 1 to the end is fine because there's nothing that's bigger than or equal to this. So we just say answer plus equals to length of SL minus BL, okay? So basically gives us what we need because it's in sorted order. So let's run this. Cool, and let's submit it. And there you go, passes all test cases. So again, I'm really happy that I solved this on my own without any assistance, although I am at the bottom of the runtime. But yeah, so hopefully this wasn't too confusing. Again, just wanted to cover this again. What that means is, let's just change this into equals. So let's say 5 minus 3 is equal to 4 minus 3. Is that true? No, it's not true because the difference here is 2. The difference here is 1. We still have one more to go, right? So if this is 5, then that's fine. If this was like 4 minus 2 is equal to 6 minus 4, that's fine because the difference is 2 is equal to 2, right? So again, you just kind of want to see, okay, how much are we missing? Can we make that inequality in the left side? So that's it for this video. Thank you for watching and stay tuned for more.